About quantum computers.
If you're a computer science nerd, you've probably heard of quantum computers. Whether or not you understand what they are and how they work is another story. Don't worry, we're here to help. This article will give you all the basics on quantum computing so that you can get up to speed and start doing some quantum computing of your own. Quantum computers are different than regular computers. You may have heard the term quantum computer and wondered what it is. Quantum computers are different than regular computers. They manipulate qubits instead of bits, which means they use quantum mechanics to perform calculations. Quantum bits, qubits, can exist in a superposition state, meaning that they can be both 0 and 1 at the same time. This makes them incredibly useful for certain computational problems, but it also means that any attempt to measure or observe these states will cause them to collapse into one definitive state or another, and this process is not reversible. They manipulate qubits instead of bits. A bit is the smallest unit of information in a binary system, and can only be one of two values, 0 or 1. A qubit is a quantum bit that can be any combination of these two values at once. This allows quantum computers to perform much more complex and powerful operations than traditional computers, which are limited by the fact that each bit can only have one value at a time. The resulting complexity makes them useful for solving certain types of problems that would be difficult or impossible to solve on conventional computers. Qubits are subject to the Pauli exclusion principle. There are only two states in which qubits can exist. They either occupy the 0 state or the 1 state. Because of this, they can be thought of as little particles that behave like spinning tops. Think tops on a table. Quantum computers are able to perform calculations using these qubits simultaneously. The result is known as superposition. Superposition essentially means that each qubit has multiple states at once. Not just 0 or 1, but both at once. This allows quantum computers to solve complex problems much faster than traditional computers can. That makes them more useful for certain computational problems. One of the most compelling uses of quantum computers is to solve problems that are difficult or impossible for regular computers. Quantum computers can be used to find the prime factors of a large number, which is a problem that would take millions of years for a regular computer but only hours with a quantum computer. For example, if you wanted to find the prime factors of a 200-digit number, a very long number, it would take an ordinary desktop computer about 2 months at full capacity with advanced algorithms. However, using Shor's algorithm on a quantum computer would allow you to factorize this same large integer in about 30 minutes. This speed-up occurs because quantum mechanics allows us to do things that traditional computers can't. For example, consider the problem of searching through all possible solutions at once rather than one at a time like classical machines do. Suppose we want to find the solution with lowest energy value from among those candidates within our energy budget. This corresponds exactly with finding highest probability states under Bayesian inference, maximum likelihood estimation. Quantum computing is an emerging field. Quantum computing is an emerging field that has many people talking. It's a type of computer that manipulates qubits instead of bits, which are the building blocks of regular computers. Because qubits are subject to the Pauli exclusion principle, they can be used for certain computational problems that would take too long to solve on a conventional computer. In fact, one of the most famous applications for quantum computers is in communication encryption. If you've ever heard about quantum encryption or quantum cryptography, or even just quantum, this is what it means. Using a quantum computer as part of an encryption scheme will make it much harder for hackers to crack your encrypted messages than if they were using modern cryptography techniques. Conclusion: quantum computers are a new technology that may be able to solve certain problems faster than conventional computers. They're still in the early stages, but some companies are already working on developing them. If you're interested in learning more about quantum computing and its possibilities for solving complex problems, check out our blog post.